Hi, my name is Bashir and I'm a network and machine learning engineer with about 10 years of experience that cut across network operations research, cloud computing, financial services, and academia. And I'm a postdoctoral research scientist at Berkeley National Lab in Berkeley, California, where I'm working on a US Department of Energy funded project called the Deep Learning and AI High Performance Networks Project. My current research focuses on developing AI and machine learning algorithms to control high-speed networks and to optimize how existing US Department of Energy network infrastructures are utilized. Now, there's a lot of talk about AI, right? And lots of people will agree with me that AI has a lot to offer. But what's quite surprising is that people don't agree what AI actually is. To help us in our learning journey, to help us understand this concept of AI, data science, and machine learning, I've adopted a framework from the University of Oxford. And in this framework, I will introduce the main concept of AI and how it's actually done. And that, of course, relates to machine learning, right? So what you will see at the center here of our framework is machine learning and the three ways in which machines can actually learn, which are supervised learning, unsupervised learning, and reinforcement learning. You will see that the cycle says deep learning. Now that's of course where a lot of excitement, has been recently, particularly with regards to image, natural language processing, and also speech recognition. Deep learning can be combined with both, supervised, unsupervised, and reinforcement learning. So what exactly is AI? In simple terms, it's the ability for machines to interpret and learn from data to make predictions, and they do so without being explicitly programmed for that. Now, in the traditional computer programming, like the coding you guys are already doing in Codecademy, the programmer defines the steps, right? But in machine learning, it's the machine that learns from the data to arrive at a prediction that they weren't explicitly programmed to do. And it's that bit that really distinguishes machine learning from a traditional programming. Now let's take a look at this framework in a bit more detail. So artificial intelligence is what we seek to achieve, and we now have machine learning at the center. So to many of us in the field, these two terms are used interchangeably sometimes, and it's for that reason that I have placed machine learning very much at the center of our framework. Now what you will see here is that there are three essential ways in which machine learning can be implemented, or three ways in which machines can actually learn from data. And what you will see here is basically the supervised learning, which is essentially the traditional way. Or let's say how, for example, a child will learn maths. You sit down with a computer, you provide the roles, right? And you do the exercises and you correct the computer whenever it makes a mistake, right? Just like how a child learns. So the computer and supervised learning learns to become better. So and traditional tools here can be things from regression, classification, right? And in regression, what we're seeking to predict a parameter. Think about, for example, maybe when a supermarket orders drink, or maybe when a restaurant orders meal, right? How much drink is needed how much drink is needed is a function of many factors, like maybe what the weather is like. Is it summer? Is it winter? Is it a weekend, or is it a weekday, or is there a large sporting event and all that? You can use machine learning to predict the demand of a particular drink, basically the demand of a particular consumption of drink, or even a meal, right? So in classification, we talk about typical problems like loans, like mortgages, like credit rating, for example. When you apply for a loan or a mortgage, right, machine learning can be used to predict whether or not you can receive a given loan or a given mortgage, or whether or not there is certain risk associated with that. This is a typical classification problem, and that again, we use supervised learning for. So on the right hand side of the framework, you will see unsupervised learning, right? And a typical question here we are asking is how this relates to clustering. Now in unsupervised learning, we do not need to provide any information to the machine at all, but we let the machine discover patterns in the data on its own. A typical question here will be, for example, associations between products, right? And we all use this all the time. For example, maybe Netflix recommends the next movie for you to watch, right? Or maybe when Amazon says customers who bought these also bought the following, this is a typical recommendation engines, and these are typical recommendation engines that are based on supervised learning and clustering algorithms. At the bottom of the framework, you will see reinforcement learning, which is a bit of hybrid between, supervised learning. But we provide a lot of information about context and unsupervised, and in unsupervised learning where maybe unlike in unsupervised learning where we provide the machine with essentially, no information about the context at all. That's what we do in unsupervised learning, right? In reinforcement learning, it's a bit different. We provide the machine, only with a reward signal. So we tell it whether, it's going to succeed or fail. That's actually determined by the reward signal. And we provide it with, series of action as to what action it can actually take to achieve a certain outcome, for example. So let's say, is it taking the right step in the right direction? It gets a good reward signal. But if it's taking the wrong step in the wrong direction, it takes it gets a bad reward. And then the machine basically learns on its own strategy on how to succeed, let's say, for example, in the game. So again, reinforcement learning has a wide range of applications, and I can tell you it's certainly one of the most exciting areas of developing AI agents, because that's actually the area I'm actually currently working on. One of the most interesting recent advances in deep learning, is actually the deep learning. So, and the deep learning is a new approach that takes, the old concept, the concept of neural network, and there adds this idea of backpropagation to create deep learning networks. I'm going to be covering this in my subsequent videos, but when you hear a deep network, it simply means it has hidden layers, right? Hidden layers within the network. But it's very important because it touches both supervised learning, unsupervised learning, and reinforcement learning. And when it's combined with any of these approaches, it can show a great impact, basically, right? It can show a great impact in terms of image, or in terms of speech recognition in particular, or even in terms of, natural language processing. And whenever you pick up your smartphone these days, I can guarantee you, you'll be using some form of deep learning network, for example, image, speech recognition, or NLP. Thank you very much for watching.